Hello. In this lecture, we are going to talk about the cross-site request forgery attack, or CSRF, or even cooler, CSRF. Now, this is a really interesting attack, which can be found in many web applications. The only disadvantage is that it requires some kind of social engineering to trick the user to open your website. So let's see how it works. The goal of the attack is to execute some kind of action in the application, like adding a new user, but to do all this without really having access to the application. The attack exploits the fact that the browser will automatically attach cookies to requests sent to the application. So let's say Facebook is vulnerable to cross-site request forgery. It's probably not, but let's say. And our goal is to post something on the target user's timeline. Since we don't have access to his password or his session cookie, we cannot really do this alone. But we know how a request to post an update looks like. So we could create a website which contains a form which results in the same request as an update request, of course when submitted. Although, as we discussed earlier, JavaScript is not allowed to send requests to any other domains, just to its origin, because of the same origin policy. Forms can still do that. So I can create a form on cutecats.com which will send a request to facebook.com. We just need to trick the user to open our website. So let's see how it works. So the browser loads cutecats.com. It's downloaded in the browser. And it had a hidden form inside, which is now in the browser. When this website is loaded in the browser, this form is submitted automatically, and the form will send the request from this browser to facebook.com. Since there was already ID for Facebook in the browser, this will be automatically attached to the request. So basically Facebook will think that this request is really originated from the user of this browser. So whatever this request requested will happen. So you wanted to post an update. So basically this request will post a new update on facebook.com and then return whatever it has to return. So the point is that the browser contains everything which is needed to legitimately talk with facebook.com. We just have to trick the user to send the request there, and because of the automatically attached cookies, it will be valid for Facebook. Facebook has no idea this is a fake request, and it will do what the request wanted to do. So let's see all this in practice. So load the voice of the emperor through burp. So our goal is going to be to use cross-site request forgery to create a new user in the application. That's a really well-known attack scenario because creating a new user is the best way to get access to an application without really having access before. So first we have to find out how a user is created, how a request to do that looks like. So go to users, and we are just gonna create a new user called test. We have to make sure that it's active and it's admin and test, and the password is test because it has to be longer than 6 characters. And I come to the history. What I usually do is, it's a little trick, but I want to record something and I have already lots of requests here that I mark here with a color to see where was I standing before doing that specific action I want to record. And then I come back here and say create. And in this case it's pretty simple, it's just 2 requests, and the second one is probably just loading the page again. So we are basically interested in this one. And yeah, you can see here that it's a post request, and here is every data what we just filled out. So this is the request, what we want to reproduce with a form. You might say that it's easy because now we have access to the web page, so we can figure out how a user is created, but how an attacker would do that without really having access to the application. Now the thing is that in most of the cases you will be able to find some way to really test this. For instance, this is an open source web application, so even if you don't have access to the particular website, you can still download the framework and create a test environment where you can check that out. If it's not an open source but a commercial application, there might be an open source version of it, or in many cases there's an evaluation version, or you can actually request to evaluate from the company, and since they will think that you are a potential buyer, then they will provide a test version what you can then use to find out such things like how to create a user. Now the next step is to create a web page which will reproduce this form. So I will just go to the root folder of the web server for www.html, and here I create a file called csrf.html. And this is a simple HTML web page, so I will just keep it as simple as possible so that I don't have to write too much. HTML body, then here we create a form. The method is post, because that's what the original request uses. And the action, it is very important, the action should point to the URL where the target is and not where this HTML page is stored. It should point to the target. So you can come to our request here and say copy URL, and here paste, and that's it. Then now we have to create input fields. If you come here, we can count how many input fields there are. It's 1, 2, 3, 4, 5, 6, 7, 8. So we need 8 input fields. First I just create a template, and then I can copy paste that. So the type is hidden because we want these input fields to be hidden from the user so that he doesn't see this malicious form. And then they have some kind of name and value and close, and we need 8 of this. So it's 1, 2, 3, 4, 5, 6, 7, 8. Actually we will need one more for the submit button. So 9 inputs, and then let's start with the first one. Token value, I will just copy paste it from here. Yes. Then real name, attacker. Of course it's stupid to create a user called attacker if you're the attacker, but you know. Bio test status, it's important that the status is active. Role, also important that it's an administrator. The name, username is attacker. Password found 1111. Email a@evil.com. And as I said, the last one is the submit button. Alright, with that our form is finished. So we close it and close the body and close the HTML. So this is our malicious website. Let's test that it works. So what we hope for is that we can trick the user to go and load our website. Of course, then it's not running a local host, and it's not called csrf.html, but cutecats.com. But the point is that he loads our website. Again, I come back to burp, can close this request, and I mark again where we were standing, and go. Now the page is loaded. Now this is where the social engineering comes in. We have to trick our user to click on this button. He clicks, something happens, and as you can see in the list, you already see the attacker user. This is what we created, and if we come back, you see that here our website was loaded. There's the content, and here's the request which was sent by our website. And as you can see, although we didn't have access to the Anchor CMS token, which is the session token, it was automatically attached to the request when it was sent from the user's browser. As I said, we still have to trick the user to actually submit our form by, defacing it to a download button or something like that, but that's not necessary, because we can also submit it automatically. So we can do it here, something like onload is document dot get element by ID. So find our form. For that we have to give a name, an ID to the form. So I will call it CSRF form. So we are searching for CSRF form. Here at the onload, we are actually executing JavaScript. So this is a JavaScript command which searches in the document, which is this web page, for an element called CSRF form, and when it finds it, it's gonna submit it. And I will just change the username to evil attacker so that we actually see that this attack was successful. You also need to delete the name parameter from the submit button because that's going to confuse our JavaScript. It's also not necessary to be there. So I will save it, and let's go to the browser, open again the localhost csrf.html. Let's go to burp suite and mark again where we were standing. And go. And as you can see, quickly the CSRF HTML came up, but then immediately after that we were redirected. And here you can see there is a new user, the evil attacker. And you could see in burp the page was downloaded, the JavaScript, the form was loaded, then the JavaScript was executed to submit the form. So a post request was sent to the website, which then redirected us to the user's page. So that's why the user's page was loaded immediately. So now you could see that it's possible to automate the attack. What the attacker still needs to do is to trick the user to actually visit his website, or what he can do is to embed his code in a vulnerable website somehow, which is visited frequently by the target user. And then when the target user loads that website, then the attack is executed. One important point is that the attacker has to be logged in the target website when he loads the malicious website, because that's how the cookie will attach to the malicious request. So that's very important. But it would work against sites like Facebook or similar, where we actually logged in all the time. Even if you don't have a tab open, the credentials are still stored in the browsers, so the attack would work. Now if we go back to our request, let's open this one. As you could see, our request is not exactly the same as the one we have seen. It's only because it's a multi-part request, but for this website it doesn't matter. It's pretty flexible from this point of view. If it would matter, then you would have to work a little bit more to create a similar request, but in our case, luckily that's not necessary. Now you could see that there was a parameter called token, which we just copied in our request. Now I can tell you right now that this parameter is actually a cross-site request forgery protection token. This site is supposed to be protected against cross-site request forgery. The protection against cross-site request forgery is to embed hidden random data in each form every time when it's reloaded. So this random data should be regenerated when it's loaded, so that every form has a unique identifier, so that the web server can see when this form was already submitted or not. So if, for instance, we use a token which was already used, then the server can check in the session data and see that this token is not valid anymore, and then just reject the request. So when the server receives a request from the client, then it has to check that this token exists, it's still valid, it has never been used before, and it was issued for the user who are actually submitting it. If any of this is not correct, then the request should be rejected. In our case, what happens is that this protection is not really working, so it's just broken. I've seen that in real life scenarios, that there was a protection implemented, but just it didn't work. What I want to say is that even if you see that the application has a protection, it still makes sense to test it whether it works or not. And even if you see that some forms are protected, there might be some other forms which are not. So it makes sense to always look for new potential attacks. So don't give up at the first sign of a protection. And if you remember, this is the protection what we turned off in the Downtown Dispatch application what we wrote in Django. CSRF can be also used to deliver other attacks, so basically to combine it with other attacks. Sometimes there's a cross-site scripting in the admin page, but the attacker wouldn't have access to the admin page, obviously, so he cannot just put the cross-site scripting there. But he can use the cross-site request forgery to trick a user to actually deliver the cross-site scripting attack to the website. So it's a really practical attack to combine with other attacks. I hope you understand cross-site request forgery now a little bit. I recommend now to experiment a bit. A really good exercise is to go back to the Downtown Dispatch, turn the protection back on, and try to change the application in a way that the cross-site request forgery protection actually works. You have to Google for it a little bit how that works in Django, but it shouldn't be a really difficult challenge. If you have any questions, start a discussion or a comment, and otherwise I will see you in the next lecture. Bye.